The second topic we need to discuss is present value. And again, we're going to start simple with a single amount. We haven't really moved beyond that with future value either. For right now, present value, and we're interested in, with present value, we want to know if we're going to get some amount, a sum payable in the future, what's it worth today? Well, it's going to be worth less than the stated amount, because if we had some amount today, we could invest it and it would be worth more tomorrow. So money tomorrow is worth, $1 tomorrow is worth less than $1 today. How much less? Well, we're going to use the formula for present value, and it's really the same formula as the future value formula. So the future value formula we saw just a moment ago, right here, future value equals the present value times 1 plus I to the n. We can do a little bit of algebraic manipulation there. We really are just dividing both sides by 1 plus I to the n, and then moving present value and future value, we're just flip-flopping the sides that they're on. But the first equation can clearly be turned into this second equation. So they're really the same equation. Once you know this equation, you know the relationship between present value and future value. You can just rearrange the terms if necessary. Right, the present value can be determined from, in addition, well, they can be determined from that formula. So if you knew the future value, we're talking about this formula right here. Now, if you know the future value, you know the interest rate, you know how many periods to discount over. Discounting is the opposite of compounding. If you know how many periods to discount over, you can just plug those numbers into that formula and get the present value. Alternatively, you can make use of a present value table. And the present value table, when we do that, we're just really taking this formula right here, that element of the formula, condensing it into what we call the present value interest factor, and this is really the present value of $1 received at some point in the future at time n. So the present value of a number we get at time n brought back to today's value. If we've got more than $1 being received at time n, we just multiply by the number of dollars we're going to receive at that time. That's the future value amount. So let's look at the table. If we're going to receive $1 4 years from now, 4 periods from now, and the interest rates are 10%, the discount rate is 10%, then the value of that dollar today, the present value, is 68.3 cents, $0.683. So let's find the present value of $1,464 received in 4 years if the discount rate is 10%. Well, we could solve that as present value equals future value times 1 over 1.10, all raised to the 4th power. By the way, there's more than one way we can write that. We could write this whole thing as 1 over 1.10 raised to the 4th. That's exactly the same thing as the term above. And the reason, of course, is because 1 raised to the 4th is still going to be 1. So we can raise the numerator and the denominator to the 4th here, and it doesn't really make any difference. So this entire amount, the present value, is going to equal 1464 times 1 over 1.10 to the 4th. So if we wanted to plug the numbers in, that's what we would do. Alternatively, we can utilize the table, and all the things that were in brackets are just condensed down into that, which we've already looked at the table. And we saw in the table, and this is for table 9.2, but it's a slide that I just put up, and the present value of a single dollar received 4 years from now at an interest rate of 10% was 0.683. We multiply that by the future value amount, and we get $1,000, which is what we would expect, because in our future value analysis, we found that $1,000 received today was worth $1,464 4 years from now. We've applied the same formula, but now we know the value 4 years from now is $1,464, and we've worked the other direction to find the value today, the present value, which turns out to be $1,000. We can see this relationship between present value and future value in this graph. Really, Einstein would be very proud of us. All that we're really doing here with our $1,000 is time travel. We're just traveling back and forth in time to find out what that $1,000 is worth at any given point in time. So we're just going to engage in some very simple time travel. The $1,000 at time 0, if we invest it, grows to 1,464 at some point in the future. Okay. In between, we could find the value of that $1,000 at time 2 right here, if we wanted to. If we know the 1,000, we use the present or the future value 2 years hence, 2 years from now. We can find the present value 2 years from now to grow from 1,000 up to the value it would be in 2 years. Likewise, if we know the value in 4 years, 1,464, and we wanted to know, well, what is that going to be worth in 2 years, we could use the present value to discount back to that point in time. So we would find, even though this time period 2 on the graph might look like it's 2 years from today, we could use the present value method to find the value of 1,462 2 years earlier, because we're moving back exactly 2 years from one to the other. So this graph, really all it's doing is illustrating the sort of time travel principle that we have for present value and future value.